All right, the second method for assigning oxidation numbers to a covalent molecule looks a whole lot like calculating formal charges in a covalent molecule. And as a result, it's easy to get them confused because while it looks a lot like it, it ultimately gives you different answers, so they're easy to mix up. But what you need to do is correctly draw the Lewis dot structure and then do a really specific calculation. It's written right here. So first, I'll remind you what formal charges looked like. So like in CH4, C, H, 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 H. For formal charges, we started with valence electrons and we subtracted the number of things that it was touching. So we subtracted 1 for each dot and subtracted 1 for each line. So in this case, we would have 0 right here, because it's 4 minus 4, and then the hydrogen is 1 minus 1, so zeros all over the place. That is not how oxidation numbers work. For oxidation numbers, you actually need to assign the electrons to whoever is the most electronegative in each bond. So for carbon, we're going to start with, I have 4 valence electrons. And now I need to subtract the number of lone electrons. It's touching 0 lone electrons. And now I need to subtract the number of bonded electrons if it's the most electronegative. So I have to look and say carbon is more electronegative than these hydrogens. So it has 2, 4, 6, 8 bonded electrons. And so I'm subtracting minus 8 bonded electrons. Remember, a bond is actually 2 electrons that are being shared. So 4 minus 8 is negative 4. The oxidation number for carbon in CH4 is negative 4. Now, all of these hydrogens are the same, so I only have to do the math once. Hydrogen has 1 valence electron. It has 0 lone electrons, and because hydrogen is less electronegative, I don't do the bonded electrons. So I subtract this out. 1 minus 0 is 1. Hydrogen's oxidation number is +1. Each hydrogen is going to have a +1. So you get minus 4 for carbon and +1 for each hydrogen. If we do H2O, we've drawn this a bunch of times, so we can just do this. Again, this is not formal charges. Formal charges, I would do 6 minus 1, 2, 3, 4, 5, 6 to get 0, 0, 0. That is how we look at formal charges. We actually need to be looking at oxidation numbers, which is a different technique. So my oxygen has 6 valence electrons. It has 1, 2, 3, 4 lone electrons. And then what is the most electronegative? Well, the most electronegative goes in the middle, so it's pretty much always going to be the center one. But oxygen is more electronegative than hydrogen, so I need to subtract 1, 2, 3, 4 bonded electrons. 6 minus 4 is 2, minus another 4 is negative 2. So the oxidation number for hydrogen, or for oxygen, is negative 2. If I want to calculate my hydrogens, 1 valence electron minus 0 lone electrons, and I don't worry about bonded electrons because they all were assigned to oxygen. So that gives me +1. The oxidation number is +1 for each of my hydrogens. And then what about a polyatomic ion? So I have SO4, which is going to look like this. And remember that it's an ion, so it has in total a -2 charge. The rules for formal charges and oxidation numbers are the same as far as what they need to add up to. The oxidation numbers must add up to -2, as well as the formal charges need to add up to -2. But how do I do all of the math? I start with sulfur is in the middle. Sulfur is actually more, or is actually less electronegative than oxygen in this place. So remember, electronegativity decreases as I go down, so the sulfur is not going to have the bonded electrons. So I start out with 6 valence electrons, and I subtract 0 lone electrons, and then I don't even deal with the bonded electrons because it is less electronegative. I end up with +6 for my sulfur. +6, +6. My oxygen, because all of the oxygens are the same, I'm just going to come outside over here. I have 6 valence electrons. I'm only working with 1 oxygen at a time, so 1, 2, 3, 4, 5, 6, minus 6 lone electrons. Write the minus sign later. And this oxygen has how many bonded electrons? Because the oxygen is more electronegative than the sulfur, I do -2 bonded electrons. 6 minus 6 is 0, minus 2 is -2. Each oxygen is going to end up with a -2 oxidation state, -2. If I add all of this together, 6 minus 8 is -2, so that all works. With this method, you have a lot fewer rules to memorize, but you are there's a huge potential for you getting it mixed up with formal charges. So just be extra careful of that. And let me know if you have any questions.